Hello, my totally sane IT enjoyers. If it happens that you choose quality assurance as a job and ever needed to schedule your tests to run overnight, or maybe you wanted to run long, complex test suites in parallel with full control without writing your own orchestration system, then you might want to consider using Apache Airflow for your QA automation. While my silly pills are still doing their magic and the order lists are busy elsewhere, let me whisper to you the gospel of Airflow, the one true orchestrator of chaos that keeps ancient horrors away from our fragile minds. Airflow is an open source platform for developing, scheduling, and monitoring workflows. It uses Python and treats workflows as code, making it highly dynamic and customizable. While it's typically used for data engineering tasks like ETL pipelines, Airflow is also a powerful tool for automation in QA. You may ask me, when should I use Airflow for my testing? Who am I kidding? No one's gonna ask that. Do you need to run your tests on schedule, maybe daily at midnight? Do your tests take a long time and you'd like to parallelize them? Want full control over the execution of each test or test suite? Need to trigger your tests only after a smoke test or deployment job passes? Airflow can handle all of this elegantly and with visibility built in. Before we start hammering away at our keyboards with caffeine-soaked trembling fingers, let us first eliminate the sacred scrolls of Airflow and grasp its core concepts. A DAG is your ancient scroll, a mythical blueprint that binds tasks into a sacred sequence dictating the precise order in which our QA rituals must be performed. Each step in your workflow is a task, an arcane invocation carved into the DAG's fabric. For QAs, these tasks may take the form of sacred trials, executing the test suite, publishing test reports to the void, and alarming whole team with the great news that prod has fallen once more. You can link tasks together to create dependencies like a finely tuned machine. Task B runs only after task A completes successfully, and so on. This setup allows you to implement complex orchestration logic with simple, clear Python code, turning chaos into order with precision. And of course, you can seamlessly integrate any test framework into this flow, whether it is the tried and true PyTest, JUnit, or even your own custom test framework born from the depths of your inflamed mind. Airflow handles them all with ease, making your testing pipeline as flexible as it is powerful. Now that you've ascended to Airflow enlightenment, it's time to summon it locally using the ancient rite of Docker Compose. First, let's create Docker file with Airflow image. It will install requirements that we will need in our testing. For demo purposes, it only contains PyTest. Then, inside Docker Compose file, we will define Postgres database, schedule container, which schedules DAGs and also runs them, web server container, which allows us to use Airflow UI, and a init container, which is responsible for bootstrapping. Once you run Docker Compose up, you should see these three containers running and be able to access Airflow UI at localhost 8080. After logging in, you'll notice that currently we don't have any DAGs, so let's create one. First, we will create a function that returns Python operator, which is essentially a task with the predefined function that runs PyTest. Then let's define a couple of mock tests, and now let's create our first DAG file. Inside of it, we define default arguments for our DAG, like amount of retries and retry delay. Then we define DAG itself, and inside Context Manager, we define our first task. Now let's get back to the Airflow UI and check what do we have there. As you can see, the DAG appeared, and we can trigger it. Task passes and we can see the logs. But that's too simple for a demo. What about more complex scenario? Remember, we've created two tests. Let's assume that first test is smoke test and second one is the actual test we want to execute. With that in mind, updated DAG should look like this. We update first task ID, as it is important that all your tasks have unique ID. We add new task, which is our actual test that we want to execute, and we set trigger rule to be all success. That means that this task will only run if all the previous tasks have succeeded. I've also added mock Slack notification task. It's not a real implementation as it's not in scope of this demo. This task has one failed trigger rule, so it will get executed only if any of the previous tasks fails. Here we link tasks together, creating graph. Trigger rules allow you to build incredibly complex logic. With all the adjustments done, it's time to check what do we have on the UI. We now have 3 tasks. We can check the graph and see that all 3 tasks are here and linked together. We can trigger our deck and see that smoke test passes, our actual test fails, and notify task is getting triggered and succeeds. Finally, I want my deck to run every day at 4 PM starting from the 1st of June. For that, we specify start day and schedule. After that, deck schedule will appear on the UI. Some may notice that I was mentioning that you can use any programming language and testing tool with Airflow. There's Bash operator that allows you to run console commands, meaning that you can mount whatever code you want and run it as executable. Also, it's possible to create your own custom operators if you want even more flexibility. Airflow is an incredible tool, however, I can't cover all of its features in this short video. Hopefully my feverish delirium helped you understand it slightly better and you'll consider using it for your testing. As for me, Silly Pills effect is vanishing and Orderly start noticing something, so it's time to get back into Softy room. Stay sane, coders!